Now we have covered all the individual circuits, that is L, C and R individually, separately, right? So next we are going to do the LCR circuit. In LCR circuit, we have to find the average power associated with LCR circuit. Okay. This time, this is, you can like draw C first, then L, then R, doesn't matter. I am trying to do what I have written, L, then C, then R circuit. There was no specified phase difference between current and voltage when we solved the LCR circuit, right? We just found out the value of impedance Z, which was under root R square plus XL minus XC whole square. Okay. So, or we are going to do it in a while. Average, the solving LCR circuit, how to solve it. But phase difference, there was no. This is average, this is EL, the voltage across inductor, this is EC, and this is ER. Okay. If we know that there is no specified phase difference, you can write E equals to E naught sin omega t and I equals to I naught sin omega t plus phi. You can also write minus phi, doesn't matter. Okay. Starting with the same equation, same point, that let dW be the small amount of work done by the source in small time interval dt, then dW will be equal to EI dt. Write that statement first and then start with this thing. Instead of E and I am writing E naught sin omega t plus, no plus, into I, which is I naught sin omega t plus phi, right? And then dt. For this part, apply the formula of sin A plus B. What is sin A plus B? Sin A cos B plus cos A sin B. See, this is how it will be. E naught and I naught into sin omega t into this part is undergoing that transformation. Sin A plus B is sin A cos B plus cos A sin B. Alright, and later on dt. If I multiply this sin omega t with this whole term, I will get what? E naught I naught sin square omega t cos phi plus sin omega t cos omega t sin phi plus sin omega t cos omega t and sin phi. This whole thing into dt. Okay. Please try to understand my bad handwriting. Now, next step comes about total work done, where we have to integrate dW in complete limit 0 to t. If I take here, first put the values of this whole dW. It will be E naught I naught. See, I am making a change in this equation. I have already multiplied this E naught I naught with this term and this term, so that I can separate the integration for both E naught I naught sin square omega t cos, this is sin square omega t cos phi. And do you mind if I also multiply dt right now? Basically you are multiplying this E naught I naught with this term and dt also, same ways with this term. So I'll have dt here so that I can separate my integration things right here. 0 to t, this thing, E naught I naught sin omega t cos omega t dt, this term and this term. Okay. Now it is easy. How? See, E naught I naught cos phi, these are constants, out. 0 to t sin square omega t, this is my integration sign dt, plus here what are the constants? E naught I naught and where is the another term? Sin phi dt. So the constants here would be E naught I naught sin phi. You are left with, within integration you are left with sin omega t cos omega t dt. We have just done that integration. While we are doing integration of this term, we do multiply this thing with 2 and divide by 2. Okay, so what do we get? We get this term gets converted into E naught I naught sin phi over 2. This term gets converted into integration sin 2 omega t dt, where this is going to be 0. So ultimately this whole is 0. Sorted. So this whole part is taken care of. Now let's see what we have to do with this part. With this, I have to first change the value of sin square omega t into what? We have also done that. This is 1 minus cos 2 omega t over 2 dt. So when I take 2 outside, I am doing it right now. Okay. When I take this 2 here, and if you open the brackets of integration, you will have two separate integration. Number one, you will have not this is the constants. Number one, you will have dt 0 to t, and number two, you will have 0 to t cos 2 omega t dt, right? This term will ultimately lead you to 0. Rest, this whole term was already 0, so it is here. This term is 0. So what exactly is left with us? We are left with the constants and integration of dt, which is capital T minus 0. This is integration of dt is small t 0 to t, and then you put the limits, upper limit minus lower limit, capital T minus 0. That means you are left with the t only. So we have what? We have the total work done, which is equal to this term over 2 into the integration of dt, which is capital T. That's all. We are left with nothing. Now I can remove like most of the part because I don't have any space, so I am doing it here. Hope you have already noted it down, or else pause the video, go back, write it down. Total work done is this. So P average is equal to what? Equals to E naught. First I write that step, total work done, which is not required though. Total work done upon total time taken. Then instead of total work done, I will be writing E naught I naught cos phi upon 2 into t whole upon t. This term goes, so you are left with P average is equal to E naught I naught cos phi upon 2. This is yes, one of the answer, but the other most important answer is instead of 2, now I am making the change here because we have already done such kind of thing. Instead of 2, I am writing it root 2 into root 2. One and the same thing. Take this separate, take this separate. So what is this? This is ERMS, this is IRMS. So P average is equal to ERMS into IRMS into cos of phi. This term is called real power. This term is called virtual or apparent power. Apparent. And this term is called power factor. And what is power factor? We will solve it in impedance triangle, which we will do while solving the LCR circuit. So the power factor, the average power associated with LCR circuit leads us to this equation, which shows that real power is multiplication of what? Virtual power or apparent power and the power factor.